Okay, what are the systems which require control or embedded systems? Okay, so embedded systems can be used in mechanical systems like car or vehicles or any other moving drives or something like that. They are required for electrical systems. Of course, now you can hear about smart cities and all those systems. So for that, to control electrical system, you need embedded systems. Electromechanical, like motor, robots and all, you need embedded systems. Biological systems, where you want to control the amount of chemical getting added, or to visualize some cells or all such devices. Okay, for example, even if you take electron microscope and all, they are mostly embedded system itself. So then after that, thermodynamics, how the temperature changes, wind is changing, or the temperature is changing from one end to another and from one block to another block. So almost all system, you think about all systems, engineering related or physics related systems or chemical related systems, you need embedded systems. For that, let me just briefly show you one of the very what to say, basic system, but very intelligent, very uh, you can say important system for our day-to-day life. This video, I was very much impressed by this particular device. Let me just show you that 2 or 3 minutes video. So this system is basically a wood cutting system, okay, where you have cutters, or you might have seen cutters in the milling, wood mills and all. At the same time, nowadays, even uh, many stores will have this kind of cutting system where the non-vegetarian items or even breads are sliced using such blades. Okay, and these are very fast. Somewhere around, they work around 20 to 25,000 rpm. So even by a mistake, if you put your finger in between, it will be chopped off. Okay, so it is very dangerous, and many people, see, many people get injured due to this kind of blades and all. So because lots of people are working, but now using an embedded system or intelligent system, you can introduce a braking mechanism which can stop the saw even before it cuts your finger. Okay, even if it, before it touches the finger almost. Okay, so it is going to keep you safe when you are working with such, what to say, instruments. So this is one of the, what to say, classical advantage or classical system which is developed by one of the companies, which actually helps to break the system or control the system before any kind of injury takes place. You see here how fast it was. That means even a hot dog, when it was introduced to this blade, it was stopped, and even the hot dog didn't get any scratch on it. So these kind of systems require, see here, this kind of system require very fast response. At the same time, just imagine how smoothly this kind of transaction is taking place, that the hot dog, even the hot dog is not getting a scratch out of a running blade which is running at an rpm of 440 or 4000 rpm or 10,000 rpm or 20,000 rpm. So this is one of the examples. Okay, so just imagine how many intelligent things are working in this particular embedded system. Of course, a braking system, an intelligent system which or a good sensor which detects the wood, or which detects the difference between a wood and a muscle. Okay, at the same time, the response time, because you don't get enough time to respond, it should stop in the very instant itself. Similarly, nowadays you can see the airbags, you don't get enough time to open the airbag. So that system should be very fast, very responsive, very intelligent, and it should work without any failure. So these kind of systems are coming up in the market just because of the evolution of the embedded system. So of course, you name it, be it mechanical, electrical, electromechanical, biological, any kind of system, if you want to develop in today's world, it is one way or the other way related to an embedded system only. So it's a huge market. Okay, so what are the important components or important blocks of a typical embedded system? So of course you will have a microcontroller's base, okay, whether it is 32-bit system or a 64-bit system or an 8-bit microcontroller or microprocessor. Apart from that, apart from the so-called the basic bits number or number of bits, you can have DACs, digital to analog converters, right? Analog to digital converters. These are all peripherals. Okay, amplifiers, filters, custom logics, that means vendor dependent logics. Apart from the microcontroller here, okay, in the center, you can have so many different peripherals, timers, UART for communication, counters. So now the thing is, depending on the requirement from the vendor or from the customer, companies, or there are some companies which design embed a microcontroller or microprocessors which can have such facilities like SPI communication, ADC, DAC, and depending on the depending on the requirements of the customer, the DAX specification can change from one microcontroller to another microcontroller. So such systems are the basic building blocks of any embedded system. So we can say that these are all embedded into one system. So nowadays you might have heard SOCs, system on chip. So chip means one particular basic IC. System means, you see here, so many things are working together to make a system. It is not just one microcontroller. It is the combination of microcontroller with DAC, with ADC, PWM, timer, and complex algorithms which makes them work together. Okay, so it is not a small thing. It takes time to understand this particular kind of microcontrollers or systems nowadays. So these are the main building blocks. Okay, now let us talk about a basic power supply, and let us see what is the importance of a data sheet. Okay, how an engineer should read a data sheet, what are the important parameters, and beyond looking into the power supply from just abstract level, what are the important things that an engineer can extract from a data sheet. So remember, in my opinion, if you want to become a good embedded engineer, okay, so if you want to become a good embedded engineer, okay, not only embedded engineer, even if otherwise you can say electronics engineer also, okay, electronics engineer, then in that case I believe you should refer to three things. Okay, one is the data sheets. Okay, data sheets, then application notes, and then of course books or standard books. Okay, so generally in universities or in colleges we stop the story here itself, right? Just books where you get some equations and you study the working of the basic concept of that particular technology, be it op-amp, timer, or any other device. Okay, but we stop here. That's the problem, I believe. Okay, most of the time in engineering we stop here, and the difference between quality universities or institutions and normal, or we can say trivial institutions, is this particular barrier. The moment we break this barrier, we will be almost entering into the industry, because industry industry work in this particular domain? Because they believe engineers whom they are recruiting already had this particular books or uh, books experience. So industry basically require you to go through these particular things. Let me just give you a simple example, very simple example. Okay. um, Wait a second, let me take one person as an example. Don't worry if you don't know the answer. Okay, it is not that you are going to get some negative marks. Okay, Chirag, are you online?
Yes, sir.
Okay, Chirag Vaishnav. Okay, so Chirag, have you worked with the power supply in our basic electronics lab?
Yes, sir.
Okay, can you tell me what was the maximum power which that power supply can generate?
Sir, I honestly don't remember that.
Okay, Ayush Merchandani, Ayush,
Yes, sir.
do you remember what was the maximum power that you can take from that power supply that you used in the electronics lab?
Uh, 12 volt as far as I remember.
Now, just imagine, this is a very common question, and I believe almost all the students, 42, okay, I believe 95% students will give the same answer, 12 volt. Okay, the question was, just now realize the importance of technical knowledge. The question was, what was the power generate, maximum power? Okay, the question was about the power of the power supply. Okay, this was the question, maximum power from the power supply. And the answer 95% students will give, it was 12 volt. So now the first question, is it a correct answer?
No, power
No.
needs
No,
No.
sir.
Power
No,
is
sir.
not voltage. First thing, voltage is a different unit. Power needs watt, right? Power is represented in watts. Now the question is, how many of you know the wattage of that power supply? I believe zero, almost zero percent student might be, or maybe 0.1%. I don't know. If there is someone who is extraordinary, who was really interested in doing practicals, he might be knowing the thing. Otherwise, I believe that most of you don't know what is the power, that was maximum power that you can extract from that power supply. So this is what the the difference between normal engineers and the outstanding engineers. Let us briefly look into the specifications of a power supply. Okay, so it is not opening. Let me go to the power supply. Let me go to the file. If I can see power supply, no. So I don't have here the power supply. Don't worry, no issues. I can just go to the website and download one power supply's data sheet. So just let us check basic difference between normal knowledge and this thing. So there are, this is one of the most reputed companies, okay, in the world. So they develop so many different devices, okay, instruments like oscilloscope, spectrum analyzer. Just go through them, at least know where these instruments are used, because in the industry these instruments are used. Okay, so first of all, let us go and check DC power analyzer, no, generators, DC power, AC power, power supplies. Let me check. Mm,
Sir, it's there in generator.
Sir, it's there in generator.
Generator, DC power supply. Okay, so for example, I am going to take this power supply. Okay, I'm going to purchase this power supply. How can I know? There are so many power supplies available. How to compare these two power supplies or different power supplies, because there are so many parameters. So let us go through the data sheet. So this is the data sheet provided by the company. Okay, let me just download it and it will be helpful in that case. Okay. Okay. So this is the power supply. Now few questions which are related to this power supply. Now first thing, when you enter into any data sheet, first few pages will give you almost all the basic features of that particular power supply or any particular device, be it an IC or anything. Now let us go a bit deeper into this particular data sheet and check what are the things available. Okay. Here here comes the technical specifications. Okay. Now first, here there is a model E36311A. It is 80 watt model. Power output is 80 watt. Can you tell me how can you justify this is 80 watt power supply and this one is 160 watt power supply? Anyone?
Sir, by checking the maximum current output.
Current output. Give me the number. How these companies are coming to that number 80 watt, 160 watt?
Sir, I don't know the exact answer, but maybe they have some testing
No,
machines.
look here. The answer is here itself. That's what I'm saying. The answer is here itself because they are giving you the data sheet for that purpose only. Just give 1 minute, observe this particular table and tell me where you get 80 and 160.
Current range.
Sir, here 500 microampere and
Microampere. Where is microampere? No.
sir,
Array,
in
look,
line-
first of all, check here. How many channels are there? 3 channels here. 1, 2, 3. How many channels are there? 1, 2, 3. Can you
The
recall?
total power.
Yeah, how many channels were there in the power supply of our lab? Can you recall? There was +5, -5, +12, -12 ground, right? And apart from that, there were 2 more channels which were providing you AC signals. So here there are 3 channels. Just do a simple mathematics. Here 6 into 5. This is the power. So channel 1 maximum power, how much you can extract from channel 1? 30. How much maximum power can you extract from channel 2?
25.
25. And how much you can extract from channel number 3? 25. 25 plus 25 plus 30. Do it. 80.
Yes, sir.
So now other things to keep an eye on. For example, this particular system 3631 is providing you more current, 6 volt 10 ampere. Here 6 volt 5 ampere. Now how that internal circuit might be designed so that you are getting more current here, whereas here you are restricting the current. So what kind of design they are utilizing or they are developing so that they can control the current also. Not only about that, this is just the wattage term. Okay, that 80 watt, 160 watt, that's okay. Next, let's go down. How many things we can extract from this particular data sheet? Series mode, parallel mode. What do you mean by that? How many of you have even heard of such terms? Series mode and parallel mode. Not available. 50 volt 2 ampere, 50 volt 2 ampere, or 4 ampere. Series means when you are going to connect these one or two or 3 channels together. Understood? Then in that case, how much maximum current or power you can generate? So this kind of technical things we should know. Okay. How many of you know about load regulation? You might have heard this thing, load regulation. Let me give a very simple example what I mean by that. Okay, so we have a power supply, okay, which is providing you a rating of 5 volt 1 ampere. Okay, so when you connect a resistance, because here you have the ground, okay, here you are taking the output from. So when this resistance is variable, so if this resistance is much greater than 1, assume it is 1 mega ohm, okay, in that case you will definitely get 5 volt here because A and B, they are having a big resistance in between them. So you will get 5 volt and the current will be very less. Yeah, current will be very less. The voltage will be 5 volt, current will be less. But what if resistance is almost equal to 0? Almost, suppose 0.001 ohm. So what is the voltage in between these two A and B node when the resistance is almost 0?
Sir, the maximum output current is 1 ampere. So in that case, voltage will drop down.
Now the question is, voltage will drop down. So the company is giving you the assurance that the power supply will be always keeping a constant voltage, 5 volt, 1 ampere, right? But when you are connecting a very low resistance, that means almost you are doing this kind of activity, 5 volt, 1 ampere, okay? And this, suppose this is the port, you are directly connecting it to ground. So this is ground here. So ground means this node and this node should be 0 volt, right? So it cannot be true because the company says 5 volt, but in reality, when you directly connect it to ground, this is the condition where you get maximum current. Maximum current. This is the condition when you get minimum current. Minimum I, maximum I. So how are you going to test what is the maximum power that the power supply can generate? Is there any idea? Do you have any idea how you can check that thing? Secondly, when you are connecting the ground here itself, you are going to damage this particular power supply because it might try to give you a current which is, because maximum I means I is tending towards infinity. When the resistance is 0, current is infinity. When the current tries to go into infinity, of course, you know, when there is a huge current, huge heat will be generated. Current generates heat, right? It generates heat. And when there is a heat, it will melt down the system. So now the question, all question comes to the power supply's data sheet. For example, here, the company is assuring you load regulation. Load means when I am talking about the output section, the resistance of the output, if I'm going to change it, how much voltage can change by changing the output load. So the voltage can change by only 0.01% or plus 2 millivolt. Here 0.01%, 2 millivolt. Current, how much current can change with respect to the loads? 250 microampere, that maximum. So these are the specifications. Similarly, line regulation. Line regulation means you are expecting 80 watt, but assume the source itself is not providing you 80 watt. What does that mean? It means all the story will work only when this power supply is connected to your main supply. How much is the maximum power that you can extract from your main supply? Power from your main supply, which is provided by the government. Government is providing you this thing. So how much is the maximum power that you can extract from this supply? Anyone, what is the maximum voltage which is coming here in this
Sir,
plug?
sir, does 220
20.
and sir,
Current?
ampere depends on
Yeah,
the socket.
mostly, but in small sockets you will get 5 ampere. So now you can easily find out what is the maximum power that you can extract from this socket, right? And now the power supply needs only 80 watt out of it. So yes, it is within the range of the maximum power which can be supplied by the external source or the government. But if assume the government or this particular supply itself is fluctuating and it goes below 80 or it goes nearby 80, will it be able to supply 80 watt at the output? No. If the source is not providing 80 watt, how can the power supply give you 80 watt? It is not a power amplifier. It is just power supply. So it can provide you a supply which is less than what is the source power supply, right? So This is called, if the supply changes or the line, if the line fluctuates, if the line fluctuates, like you might have seen sometimes in the wind, in the rainy season, the power is fluctuating, right? Or even in the summer, when all of a sudden all the colony members, or the village or in the town, people starts using air conditions or coolers, suddenly our voltage drops down. So in such cases, when the voltage of the line itself is dropping down, how much power will be changing at the output? That means if there is any change in the input, then how much change will be we can expect at the output? That is called line regulation. Line regulation. So now the question here is, a good power supply should maintain the line regulation. Even if the power supply or the line is changing its voltage, it should still maintain a decent 80 watt, pure 80 watt. So here you see again, this kind of things are there. So unfortunately you are not in the lab, otherwise you could have gone to the lab and tested directly on the power supply that we have in our lab. So there are so many things that you have to keep in mind while doing this kind of tests. Apart from that, you see here accuracy after 12 months, right? Then read back accuracy. So how many terms do we know or do you know about the power supply, right? So these kind of things you can only know when you go through the data sheet. The more you go through, or the more you get deeper into the data sheet, the more you will learn. We will come to the data sheet more deeper. We will study about more deeper topics of the data sheet when we'll be studying about the microcontroller. Okay. So these are the things. It is not just a power supply. You have to have decent knowledge about the power supply, because that is going to control your microcontroller or microprocessor. Okay, just go and do one small research. Okay, this is one suggestion from my side. Do a small research. Nowadays, whenever you're taking any microcontroller board, right, you mostly use batteries to supply power to the microcontroller board, right? And then of course you can connect some LEDs or motors or something like that, output devices. Now the main power is provided by the battery. How many different types of batteries are available in the market? How many different types of batteries are available in the market? Anyone?
Dry cell, lithium ion.
Okay,
and
wait. Dry cell, then lithium ion, then
Lead.
then lead acetate.
dry cell. Okay, then any other? Lithium ion, lithium polymer. Have you heard of lithium
Yes,
polymer?
sir. Yes, sir.
And then if you go and search now, you will find there are more than 10 or 20 types of power sources in the market. So do you know what are the specifications of these particular batteries, or what is the difference between a battery and a cell?
Collection of cell is known as battery.
Battery is nothing but collection of cells. So when you have this kind of structure, okay, this kind of structure, you call it a battery, right? And this is cell. No, right? Now the question is, individual cell of lithium ion, lithium polymer, dry cell, do you know they have different voltages? Some of them work at 3.2 volt, some of them work at 3.7 volt, and so on. Dry cell or the pencil cell that we purchase in our for our clocks and all, they get 1.25 volt. So when you combine these cells, you can get a multiple of these particular numbers. So these kind of things are there. Secondly, how much time they take to charge, how much time they take to discharge, what is the behavior of discharging, are they discharging, for example, time, And here you have a load. Load means if suppose you are connecting only 100 ohms to these batteries, so you will find that some of the batteries discharge like this, some of them discharge like this, some of them, okay, discharge like this. Please go through them, because these are the things which are required to design a good embedded system. And having a knowledge of these kind of technical things can improve the quality of your embedded system. Just do small research, okay, that will be very helpful, because these are the things which people generally don't know. Okay, for example, types of battery and their responses. Just type like this, something like this, and just go through the images. So different types of batteries are there. There are many useful websites, okay. And for example, like this kind of responses are there. So do study them. It will help you in long run, because when you go for an interview, the companies generally expect engineers to give or to have at least this kind of knowledge, how they discharge. Okay, what are the generally, oh, sorry, what are the basic voltages at different batteries, types of battery and their voltages, types of cells and their voltages, because battery, okay, it is common word anyway. See here, this kind of tables, go through them. Okay, alkaline battery 1.5 volt, approximately energy density 0.5, zinc carbon 1.5, lithium 3 volt, lithium manganese dioxide 3 volt, lithium sulfur oxygen chloride 3.6. So please go through this kind of tables. Okay, keep them with you, so that you should know that, okay, if you tomorrow you are going to design any project, how many different voltages or how many cells will be required to provide enough power to your system. Are they rechargeable or not? What are the internal resistances, power density? This kind of things are expected from any engineer who is going to work in the embedded system. So there are so many things that you can explore anyway. Now proceeding to the next, power interface. Of course you will need power interface when you need to have power amplification. There is a difference between power supply and power amplify. Amplify means increasing the power. Okay, so in the last class I showed you basically connecting a transistor to increase the power. From the source you were getting a very small power, but at the end you were driving a motor with a larger power. So that kind of things are power amplification, and for that we use transistors. Okay, transistors, MOSFETs and all, so that you can should be able to handle power requirements divided by actuators or high power devices. High power devices. Okay, so power is no doubt one of the most critical thing, and again I am focusing on that, because even if you know the basic terms of power supply or power related sources, you can get a good job, because now companies are finding the best suitable power supplies for their products, be it a car, be it a mobile phone, be it a sensor network or anything, because that determines the life of the system. Okay, anyway, next, now let us go and check a small survey. Okay, these are all taken from one particular survey. I found it very important, because before entering into embedded system you should know this kind of stuffs also. Okay, this was a survey conducted in 2019, so it is very close, it is not too very old survey. Okay, um, now the question was, because this is one, you can download it from the internet also, there are so many things that they have surveyed in the market, but I found some of them very important to be discussed here. So how much embedded system is used in different markets? For example, in industry, consumer electronics, IoTs, automobile, medical line, military, audio related devices, video related devices, and so on, security related devices. So most of the industry right now in 2019, mostly maybe 1 or 2% fluctuated in these 2 or 3 years, but it is almost the same, I believe. Around 35 to 36% people are using embedded systems to automate or control industries like steel factory, car manufacturing companies, and so on. So embedded systems are used in almost 30 to 35% in the automation industry. Then, of course, consumer electronics like your mobile phone and all, still they hold 30% market. IoT related devices, for example, here you see in 2015, the market was only 19% IoT related. But from 2015 to 2019, the market has jumped to 25%. So just see how much growth is there in this particular IoT market also. Military and aerospace, they are almost constant. You cannot say they are decreasing, they are almost constant, right? So other than that, security, municipal, transportation, they're almost constant. So embedded systems, depending on this, you can choose your final goal, in which industry you can find a good job. So keeping that in mind, you can progress in that particular direction, provided you should make your project in that direction if you are planning to go into this industry, right? So most of the embedded systems are used in industry, consumer electronics, internet of things. When we say consumer electronics, even toys are considered in that. Okay, toys. So consumer electronics and communication and network. Of course, automotive nowadays is going to boom in the coming years. This particular section definitely will increase to, that means exponentially in future. So this is the areas in which embedded systems are there. Apart from that, most of the time spent by the engineers, when they are embedded engineers, where they spend most of the time. First of all, 13 to 14% time they spend on developing the system specifications. So just if tomorrow you are going to design your project, these steps you have to keep in mind. How much time you should give to design a good project. So if you are assuming that in 100 hours you are going to complete a project, keep at least 15% of your time, or at least give 15 hours to discuss the specifications of your system with your team. Okay, what are the specifications that we are going to achieve? Then after that, 10% time is spent to design the concept. That means, okay, specifications are here. How can we bring those specifications into our system? Then 4% time they spend on security related issues, like no one else should be able to break that system. 4% time. So if you are not interested in security related device, if you are just planning to design something very basic, leave that part. Okay. Most of the time goes in this particular part. 30% time detailed designing stage, where you will have your circuit design, the components, what kind of components you want, whether it is an expensive component, are there any alternative solutions for that particular chip or any IC. So detailed design. So if you see here, this particular two things, system specifications and detailed design stage, takes around 50% time. Then after that, simulation takes 10% approximately. So 10 hours you will take to do simulations. Testing and debugging takes more time, at least 20%. That means 2 times of the simulation. So once you have simulated it, it might be working in the simulation, but when you bring it to the hardware testing level on the breadboard or on the PCB, you will find it is not working. So most of the time you spent in simulation, suppose it is 10 hours, you will be spending 20 hours to debug it or test it in all the conditions that you are planning. For example, when you specified that it should work at 20 degrees Celsius, 40 degrees Celsius, 100 degrees Celsius, you should go and check it also whether it is working linearly in 10%, 10 degrees Celsius, 100 degrees Celsius, 150 degrees Celsius or not. All such testing has to be done, which takes a lot of time. Of course, last, prototyping, making a model. It is not the product. Okay, prototype means just a model which is almost fully functional. So it takes only 10 hours almost. Then of course, transitioning to product. That means prototype to product will take only 6 hours or 6% of time. So most of the time is spent in developing the specifications and detailed discussion. So discussion, if I go in a more technical way, then technical discussion, okay, or brainstorming takes the maximum time. So until unless you have a good team, you cannot do a good discussion. And without good discussion and good brainstorming, you cannot come up to a conceptual design. And until unless you can have a good conceptual design, you will not be able to simulate something or to test something. So everything, these things are blocked until unless all the previous things are planned in a particular way. Okay, so this is very important when you are designing something in future, even if you are going for software or something. But in embedded, this is the ratio of the power which is divided among the embedded engineers. Okay, apart from that, what are the experts that they are saying where the future is? Future, considering, okay, that means most of the engineers are planning, or they were planning to move in embedded vision. Embedded vision means even LDR, that means lidar kind of technologies, or you can say there are headsets which can give you, which are used to play video games, virtual games and all. So embedded vision is one of the hottest topic, and definitely machine learning based systems. Machine learning on computer is different, and applying that machine learning on a system, on an embedded system, is a different thing, because computer is not going to work in the hospitals. Computers are not going to work in the defense or on the missiles. In the missiles, in the hospital, embedded systems work. On your wristwatch, the embedded system works. So if you have a very big computer and with a 16 GB of RAM and 1 terabyte of hard disk with i7, of course your model might be working there. But when you bring that same program to a smart wristwatch which has only 2 KB of memory, it will not work, because even your code might not be able to get into that particular memory. So machine learning or deep learning should be applied. When you go to apply it in real world, it becomes a very challenging thing. So this is very hot topic now. See, 55% engineers are planning to go into machine learning based capabilities using embedded system. Of course, apart from that, AI and cognitive capabilities, virtual reality, video games and all, augmented realities, these are the hot topics of this particular coming era. Okay, so bringing the things that you do in the computer to an embedded system is what the market is demanding. Might be possible you can do all the simulations in the computer, but when you bring into an embedded system, nothing will work, because there are so many bottlenecks. We will discuss it later. Okay, these are the things which, if you want to go into a job, these are the areas where you can focus now, or start working, designing projects in these particular domains. Okay, so now the question was there, how many engineers are we using which kind of language? Be it any engineer, be it in computer science or analytics or embedded system, you will still find very huge or a large chunk of engineers are still using C, especially at least in embedded systems. You see the market share is still around 60%. So around 60% engineers are using C. Rest, approximately 25% engineers are using C++. Python, in the year 2019, only 6% engineers were using Python. I will come to that why and what are the other available options. Okay, anyway, what are the challenges in Python and all. And apart from that, 4% engineers are using assembly language. Rest, Java, MATLAB, LabVIEW, C, Hash, these are other languages which are used to control embedded systems or to design embedded systems, but very rarest of the rare engineers are using these languages, because most of you can directly see what is the crux here. The crux is these are high level languages. These are high level languages, very high level languages, okay, or we can say abstract languages, whereas this one is not high level, but neither it is a low level. So it is in between the high level and low level. Okay, Python is a high level language. So this C is after embed assembly language or machine language. This is the closest language to any hardware, closest to any hardware, okay, be it any your computer itself. I will demonstrate that C is very close to your hardware itself. Okay, so that's why when you are designing any hardware related solutions or embedded solutions, C is considered to be the most appropriate language for designing any embedded system. So this is why I am going to work in this particular language to cover the course. Okay, so 60% engineers are working in that domain, and even your seniors, if you ask them, 99% of them are working in C if they are working in embedded systems. So this is very important. Okay, okay, so these are the all market related details which will help you or guide you to decide in which direction you should go, which language you should use, which technology you should follow and all. Okay, so which are the biggest companies which are producing microcontrollers currently? Okay, NXP, have you heard of NXP? How many of you have heard of NXP? Before it was called Freescale. Freescale. You might be knowing Intel, AMD and all these companies, right? But how many of you know NXP? Okay, how many of you know this company, Microchip? Anyone who knows Microchip?
Yes, sir.
How which microcontrollers are produced by Microchip? Acha, how many of you know Arduino?
Yes, sir.
Yes,
You
sir.
almost everyone knows Arduino. Okay. अच्छा चलो तो Arduino में चलते हैं. You know about Arduino, right? Arduino Uno. This is the most common board which is used in almost everywhere in the market. Okay, so Arduino is a company which uses microcontroller to design the board. Okay, let me just copy this. Okay, so paint, and let me rotate if I can rotate by sorry, Control Z, Control V, vertical, and then horizontal.
So wasn't
Okay.
it made by Atmel?
Yeah, you see here, I believe you can see my screen. Atmel, here you see Atmel. Atmel Atmega 328 here in this region. Yeah, here you can see, I believe, here this thing. Atmel Atmega.
Yes.
Atmel Atmega 328. So this particular IC, Atmel company was developing this IC, Atmega 328. But later, Atmel company was acquired by microchip. So now microchip is the main company which is producing Atmega 328, which is used in Arduino Uno. Almost all the Arduino boards, be it Arduino Uno, Due, you name it, okay, Nano, all these boards mostly use Atmel chips, or now you can say microchip. Okay, so then of course after that there are some big companies which you know, Samsung. Samsung produces large scale of your microcontrollers, and then STM32 and all, Infineon, Texas Instrument, TI. These are the companies or giants which produce microcontrollers. Microprocessor, of course, Intel, AMD, and all, but even Samsung produces microprocessor and microcontrollers. These are the companies which are giants in designing microcontrollers. Okay, so if you are planning to move into chip designing or IC designing technologies, focus on these companies. These companies are big companies. Okay, and check what kind of research they are doing in their website. Go through and study in free time. Okay, so where are these ICs getting implanted nowadays? Okay, in 2018, okay, it was found that most of the ICs are nowadays implanted into automotive industry or automobiles. How many of you know that currently we are going through a chip crisis?
Yes, sir.
Yes.
Yes, sir.
किसी ने सुना है मार्केट में चिप क्राइसिस है?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Please go through it and go through the news. Okay, most of the companies, automobile companies, you will find automobile companies. You see here, I just typed chip crisis. Toyota cuts back production by 20% amid chip crisis. You name it and you will find all the companies are going through this chip crisis. Okay, so it is very clear that if there is any downfall in chip making or chip production or IC production, they are going to hamper the automobile industry. So registration of new passenger cars in European Union slid by 2.4% in 2021 to 9.7 million vehicles. Worst performance since the statistics began in 1990. So the statistics started in 1990, and from that date till this date, this is the worst performance of any of the automobile industry, because they have stopped or halted the production because of chip industry. So can you see the correlation here? So please do go through this kind of reports also. It will help you to not only invest in the market, if you are good in stock market. Apart from that, it will help you to become a good engineer also. That okay, when you should make a switch from one company to another company. Okay, consumer electronics like mobile, home security systems and all, lifts, and this kind of systems are taking another big chunk. Okay, industries, manufacturing companies and all, they take huge chunk also. So then of course medical devices and military devices. So these are the ICs which are, these are the industries which are consuming these microcontrollers. So there is a huge demand in every field, you can see. Okay, and if you go from cost perspective, I can guarantee you that military devices or military related devices or embedded systems cost the highest. Then after that, medical. Okay, so if I say military takes this many dollars, then medicine will be taking these many dollars, and rest these are consumer electronics, the cheapest. Okay, because they don't have to go through stringent regulations and all. So medical devices and military, if you are good in understanding those terms which are used by the doctors and the military or army personals, and if you are working in such projects, you will get huge salary, that's for sure. So the highest salary you can get is from the military and defense, And of course, if you are working in medical uh, device designing companies, I can give you a good name. This is GE Electricals. Okay, if you can focus on this company, these are one of the best companies which are developing medical equipments and devices, be it ventilator, thermometer. Not apart from that, there are so many other medical equipments which we don't know the names also. So if you design some projects related to that, these companies can easily give you internship and they can easily absorb you, because the rarest of the rare engineers, they know this kind of devices. Okay, anyway, so this was all about the market and their market strategy, and this is what the prediction in terms of the growth of embedded systems and their market share in terms of dollars. Okay, so apart from that, now you can see here, this thing you can leave is the market. You don't have to look into the market, but this here is an important graph. So in the very beginning, there were 8-bit processors of microcontrollers, even your Atmega 328. Okay, at Mega 328 or Uno uses 8-bit microcontroller. 8085 was 8-bit microprocessor. 8051 8-bit microcontroller. Atmega 328 8-bit microcontroller. Then came the era of 16-bit microcontrollers and then 32-bit microcontrollers. And now, of course, 64-bit are also made in the companies. So the share here, you can see the 32-bit processors are nowadays becoming more and more popular. Of course, this graph, if you see the growth, is almost linear or almost stable. There is no huge jump in the market. But if you see the market share of 32-bit microcontrollers, you can see the growth is very large. See here, the difference between this region and this region, you have a very big rise in demand for 32-bit based microcontroller or microprocessor systems. Okay, so we are going to study 32-bit microcontroller in our course. Okay, so these are the reasons why I am opting such a board with such specifications. Okay, now, okay, what are the system requirements? Of course, you should have a computational power. Programming should be easy. Speed of operation should be fast. These are the normal things which we all require or expect from any embedded system. There should be good number of interrupts. It should be reconfigurable. That means if tomorrow the project requires something else, the same microcontroller should be able to be reconfigured to design a new prototype. Power and heating should be less. It should be able to interface with many peripherals or communication modules. Overall cost should be less. It should be versatile. These are the things which are generally no, you can put numbers in them and try to put some numbers in them, because if you can put some numbers, then you can become a good engineer. When we say computational power, okay, this is a vague word in one way. Computational power, everyone can say good computational power should be there, but can you tell me what is the unit of computational power and what kind of computational power are considered to be decent computational power? Anyone? Because these words are commonly used by the engineers, but can you define it in some numbers? Because we engineers work for numbers only. Anyone?
Instructions per
The
second.
number of instruction per second.
Okay, you can say number of instructions per second. Okay, but if suppose the company says my microcontroller is able to compute or complete one instruction per cycle, two companies are coming to you and they are saying both companies can complete one instruction per second, per clock, sorry, not second, it will be very slow then, per clock. Okay, and the second company also comes and says, okay, my microcontroller can also complete one instruction per clock, and both of them are working at 25 megahertz. So computational power is almost same now, right? What other features can be considered when you are talking about computational power? So please take note of these terms and try to put some numbers in them. For example, when we say memory, okay, memory should be large. Any XYZ engineer can say memory should be large. But how many different types of memories are there? For example, cache memory is there. Then you have RAM. Then you have ROM. So in general, what is the size of these memories? If you know these numbers, then you will be making sense. For example, if you go to an interview and you, before you, suppose someone else went to the interview and he said there should be big memory, definitely the company will say, okay, big, what do you mean by big? So if you don't know the numbers, he will be rejected. Whereas if you can say, sir, I expect this much of cache should be there, RAM should be this much, and ROM should be this much, in that case we can complete this project. Now you make sense, and you definitely deserve more money than anyone else. So please, these 19 terms are there. Okay, availability and all, you can, versatility, you can just keep it apart. But apart from that, um, these terms, ease of programming, speed of operation, number of interrupts, reconfigurability, heat, how much heat it can tolerate, okay, before getting disrupted, overall cost, leave it, safety, leave it, communication requirements. How many of you know what are the different communication modules which are available in embedded systems? What kind of modules you can expect? Okay, 8085, how many of you remember 8085? What are the different communication protocols available in 8085? Have you heard of UART?
Yes, sir.
We have discussed in 8085 UART, but now there are SPI, I2C, okay, and then USB. USB is a communication protocol, okay, and so on. CAN network. So these are all communication protocols. So how many communication protocols does your microcontroller support? You should go and investigate those things. Okay, EMI, EMC. I will come to that also, why it is very important. Okay, these are the very important technical terms which can be brought down in some numbers. Okay, and that number makes sense. Please go and investigate and put some numbers in front of these technical terms. Okay, then only you will
So
be
what does reconfiguration mean?
reconfigurable means, for example, you are designing some project. Suppose you have a microcontroller and you are designing a project for vending machine, right? Vending machine. In that vending machine, suppose initially the company said, okay, we are making a vending machine for 3 cross 4. That means 3 rows and 4 columns, right? So that means 12 products, right? Clear? What do I mean here? 12 products, okay. 3 rows and 4 columns are there, and the vending machine will contain 12 products. Tomorrow the company came and say, yaar, ek saal ho gaya hai. Now we should expand or bring a beta version of our vending machine. So vending machine alpha version, and the company came with a beta version of vending machine. And in that, suppose they say we now should go for 6 cross 4, okay, or 6 cross 8. That means it should have at least 48 products in our vending machine. Now, can you reconfigure the same microcontroller or the system to this level or not? Otherwise, you will say, sir, now if you are going to go for beta version, we should change the microcontroller itself. Now, if you change the microcontroller, again the engineer will study the instruction set, the data sheet, the protocols or the communication protocols available. All these things he has to again go through the data sheet. It will take much more time to switch to a different version or reconfigure the system. So, is it easy to reconfigure from one model to another model or not? Or sometimes even can you use the same code which you have generated for one particular microcontroller, can you bring it to another microcontroller, right? So these kind of things are considered under reconfiguration. So this
So
is
wouldn't
important.
that be the same as upgradability?
No, upgradability means suppose you have developed a 16-bit microcontroller based system, okay? And now you want to upgrade the same code or to go for a system with 32-bit system. So upgrading means you are changing the whole platform itself. Here you don't want to change the platform. You keep that same platform, but can you change the way it is working? Understood? So this kind of things are there. So keeping the base same. For example, do you know most of the companies are in the vehicle market, they have the same base, and on top of that they just change the body. The engine is same, almost seating capacity is same, just the body is changing. So they have the same base platform, so it is reconfigurable. When you say upgraded version of any car, that means now you have improved the engine itself, or you have changed the number of seats in them. It is an upgraded version. Understood?
Sir,
Hmm.
the difference between computational power and speed of operation.
Speed of operation means I will come to this. Speed of operation, how we can check. Computational power, that's the thing I'm saying. It is not a simple term in terms of clocks per instruction or instructions per clock. It is not that. Here you can say speed of operation is instructions per clock. It can be easily defined here, but computational power cannot be defined just with this particular parameter. It needs many other parameters to bring into the in this particular term, computational power. For example, does it support multi-threading or parallel processing? Understood? For example, here when you go through this kind of term, it is not just about instructions per clock or number of instructions per second. Here you need whether it can do parallel processing, multi-threading, can it support this kind of programming techniques or that kind of programming techniques and all. Okay.
Yes, sir.
It is a very big word. It is not just one small term. Okay. So please go through these 19 terms and please research on whether you can put some numbers in front of these terms. Okay. That will help you to understand embedded systems. Okay. Software comparison. So when we go for studying a software, the softwares can be defined into many different levels. We say sometimes high level languages, and these are low level languages. Okay. Or we can say these are abstract language. Abstract means the engineer do not have to know about what is happening inside that particular code. They are having good big libraries, and you don't know what is written inside that library, and you can work with that. So these kind of languages are very easy to learn. Of course, they are very easy to learn. Arduino IDE, it is very easy to learn. Even a class 5th or 6th student can start working with the Arduino IDE. With C or C++, it is not that easy, but still okay. You can create your own functions. You can give name to your functions. You can name according to the requirement, like LED bulb or something like that. But it is not that easy as Arduino. Moderately easy. Difficulty is moderate. But ASM, assembly language, it is challenging because you have to read the instruction set. You must know how to uh, read the instruction set, at the same time write bit by bit, sometimes byte by byte. So it is very challenging. Okay, so challenge is there. But coming to the second parts, libraries, availability of libraries, these are nowadays very very important, because if you see why people are going for Python, okay, and why people are not preferring assembly, because okay, on one hand you have ASM and on the other hand you have Python nowadays, or R or any other language. So why? Because you have too many libraries available in Python. In ASM, no, there is no library. You cannot create a library using a ASM. Whereas in C, C++, yes, there are many libraries available in C, C++ also. That means when we say library, for example, a function like add is a library part of library. It is a function which allows different functionalities, or even libraries for different peripherals. You don't have to worry about anything. They will give you the whole library or written program for that particular hardware. We will come to that. Okay. Speed. When you go for speed, these are the slowest. Okay. Be it Python, be it any other language. When you go for speed, when the speed matters, no one cares about high level languages. They avoid high level languages because you don't know what is running behind that function. I will give you a very simple example also. Okay, don't worry. So they are damn slow. But when it comes to assembly language, very fast. So nowadays, combination of these two are used to design good driver files. That means some part of the program will be C, and whenever you need very typical activities to be done in very small time period, you will go for assembly. Mix that two and make a good language, okay, or good program. So these two are nowadays integrated together. But apart from that, assembly is the fastest. If you need speed, assembly, like airbag or uh, the SOM that I showed you, where the time is very critical. It is not that you can wait for half an hour or 2 seconds or 10 millisecond to get the response. No, by that time you will be dead. So time critical instruments or devices need assembly. Or otherwise, you can definitely go for C also. Okay, but not as fast as assembly. Assembly is the fastest. Features that you can use, that means all the features of a microcontroller that you can extract using Arduino or abstract level languages, very limited. You cannot, that means push the IC to its limit using abstract languages. So to access all the features of a microcontroller, you must or you should always go for assembly language. But again, it is very challenging. But with C, especially with C, you can access almost all the features of a microcontroller. All the features. Okay. So this is the trade-off between uh, high level languages and low level languages. So these are for, in short terms, we can say these are for kids and these are for men. Okay, don't feel that I'm only going for gender. Okay, for women also. Okay, so kids and these are for boys or girls. Okay, boys or girls, because the maturity comes with these particular terms. How skilled you are, that will separate you from other engineers. Okay, so let us go a bit more deeper. These are very common statements. High level languages, program friendly, machine friendly. um, it is less memory efficient. These are memory efficient. I can prove it. Okay, it is easy to understand, it is tough to understand, simple, debuggable. These are simple terms which you all know. These are the simple answers which are given in the viva. When no one knows any answer, they come up with these kind of answers. but but can you justify it? Okay, So, for example, this is one very good image. So, hardware is here. Hardware, your IC, your microcontroller, microprocessor. Machine language stands here, where machine language means 0 1 0 1 1 0 1 1, this kind of patterns of zeros and ones. Of course, we cannot read all these zeros and ones. From that, we can go to assembly, where we studied about move A, comma B in the last course. Move A, comma B, add B, rotate B, or no, this kind of things are there. These are assembly languages. Then you go to a second level, which is called high level languages like C, Fortran and Pascal, and of course nowadays Python and all. Okay, so the higher you go in terms of language, you can see the farther you are moving from the hardware. Okay, so if you want to remain close to the hardware, you should remain more close to such languages which are low level languages. So here you have low level languages, here you have high level language. The higher the language, the farther you are from the hardware, आप उतना उसको कंट्रोल छोड़ दोगे. So if you want to control it in a very proper way, then you should go for low level languages. Okay. Before this, let me show you a very simple example. Why I am calling it mm, high level and low level languages. Wait. Okay, close this. I don't need this thing. I was having an Arduino board with me. Let me check if I have the cable with me. Uh-oh. This is something wrong. Okay. Okay. Let me just try without the board. Okay. So Arduino is opening. Okay. By that time, I can open one more important window. Okay. So Blink program using C. Okay. Something Arduino Uno. And what happened to my Arduino? It is opening. So here. So let me just check what I mean by that, because these are simple examples which will help you to understand what is the difference between um, the embedded files or embedded C versus your Arduino program. Okay, so this is the program which is generated by the Arduino, and blinking an LED using embedded C. Wait, yeah, there is a code. I received the code, but oh wait, this is the same website. Okay, let us check. So this is the code which is there with the Arduino. I believe you can see this code, right? So if I compile this code, so when I am compiling this code, let me check if I can show you the, because I don't have the cable with me. Compiling the sketch, and it's taking too much time. Okay, here for example, let me just briefly discuss about this pin mode. What is the function written behind the pin mode? We don't know. What is the function written behind the digital write? That means this is a function. Here you can see digital write is a function. So what is the code behind it? We don't know. For example, delay. What is the code behind the delay? So now, for example, what I wanted to show you, after compilation, you can see one message is here. It says sketch uses, I hope you can see this, right?
Yes, sir.
Okay, so here it says sketch uses 924 bytes of the program storage space. Maximum is 32 kilobytes. What does that mean? That means the flash or the flash memory available with Uno is 32 kilobyte. Out of that 32 kilobyte, 924 bytes have been consumed. Almost 1 kilobyte has been consumed. For what purpose? Only for blinking an LED or making an LED on and off. Okay, apart from that, how many global variables are there? 9 bytes have been consumed by the global variables from the dynamic memory or the RAM. So RAMs 9 byte have been consumed, leaving 2039 bytes for local variables, or maximum RAM size is 2 kilobyte. So flash 32 kilobyte, RAM 2 kilobyte. Out of that, 9 bytes of RAM have been consumed. 1 kilobyte, almost 1 kilobyte of flash has been consumed, only to match or meet the requirements of this blinking an LED. So this is an abstract level language. Okay, what will happen if I use embedded C instead of that? Okay, this is AVR. Okay, no, I will need. Okay, I can try this. Okay, no issues. AVR means at mega. Okay, so this control A, control V. So what we are doing here, defining the clock speed 16 megahertz, calling a library, another library for delay, and then this is what embedded C is used to do the same task for blinking an LED. If you have an Arduino board, you can try it. Otherwise, you can try it with the even with the Tinkercad. Okay. Now let us compile this software. Okay, desktop. I will just make one folder. Just give me a second. New folder. Delete it. Okay, test. Okay, now let us see the difference between the compilation report from the previous and this one. Then after that I will end the lecture, because till now it is this is what I wanted to teach today, that why we are going for C, and what are the things which motivates an engineer to go for this kind of languages and all. See here, what is the difference? Now you can see, when you are using abstract level language, it was using 1 KB. 1 KB out of 32 KB, 1 KB for blinking an LED, to make an LED on off. If you use embedded C, see how much bytes it is taking? 162. What does that mean? Now if you compare these two, how much efficient this particular program is. So you have reduced from almost 1 kilobyte to almost 150 kilobyte. It is a drastic change in using the space. So you have almost the whole memory with you. Okay, so 162 byte and 924 byte, first comparison. Second, here you are using 9 bytes of RAM, here almost 0 bytes of RAM. So your whole RAM is almost vacant, free for use. and you are achieving the same task. So now can you see the difference between a programmer who is using a program which is based on abstract level language and a program which is used using embedded C? But of course, when you go through or study this kind of code, you will find it difficult. You will say, okay, this is difficult. But no, if the from the very beginning, if you would have been teaching this kind of stuff, you would have enjoyed it. Okay, so please try this and see the difference of the speed and all. Okay,